Hi guys, welcome to the sixth and final video in our kinetics unit. This video is going to be all about catalysis and the use of catalysts in a chemical reaction. So catalysis, the word itself, simply means acceleration of a reaction by a catalyst. So when you hear someone say catalysis, that just means that you used a catalyst to increase the rate of a reaction. So we've talked about a catalyst before as a substance that changes the speed of a reaction, but it's not used in the reaction. So it's something you just use to speed up the reaction. And it actually works by providing an alternate reaction mechanism for the reaction. So what a catalyst does is it actually lowers the activation energy of the elementary step by stabilizing the transition state. So remember, activation energy is the minimum amount of energy that you need in order for a reaction to occur. So the catalyst actually lowers that activation energy. It makes the transition state, which is already at maximum energy, it actually makes it more stable, which in turn minimizes the energy. So by lowering the activation energy, that allows for more molecules to have that amount of energy, and more molecules can react, which means we have more collisions and we have a higher reaction rate without changing the temperature at all, right? Because a lot of reactions are temperature sensitive, so a catalyst allows us to change the rate without changing the temperature. And then a catalyst can also provide an alternate by forming a new intermediate. So when we form a new intermediate, that actually will change the mechanism of the reaction altogether. So there are a few different types of catalysts that we can have. We can have a homogeneous, a heterogeneous catalyst, or we can actually have an enzyme. So a homogeneous catalyst is simply a catalyst that's in the same phase as the reactants. So for example, if we have a gas phase reaction, then if it was a homogeneous catalyst, it would also be a gas. A heterogeneous catalyst is one that's in a different phase than reactants. Often we see a heterogeneous catalyst used when we have a gas phase reaction and we use a solid catalyst. So what actually happens is the gas is passed over the solid, and then the solid is what the catalyst is. And then we have enzymes. Enzymes are a specific type of catalyst, specifically used in biology. So an enzyme is a catalyst that's in a biological system, and what it does is it actually binds to a reactant in order to lower the activation energy or form a new intermediate. And what happens is we have what's called an active site of the enzyme, and the substrate, okay, or the reactant will actually fit into the active site of the enzyme, much like a key in a lock. A lot of times you hear it called the lock and key model. An example of an enzyme is actually catalase, which is an enzyme that is in the liver. And what it actually does is it speeds up the decomposition of hydrogen peroxide, because at high concentrations, hydrogen peroxide can be very dangerous and potentially lethal. So with catalysis, there are a few different types of ways that we can catalyze a reaction. One is acid-base catalysis. So we can use acids or bases to catalyze a reaction, or we can use surface catalysis. And surface catalysis is just when we run usually a gas over a solid. So we simply increase the number of collisions by running the reactants over the surface of the catalyst. So some examples of catalysts that we see a lot are catalytic converters. So automobiles, cars are equipped with catalytic converters, and what happens is the gas from the exhaust is actually passed over a surface that's covered with a specific catalyst. And what it does is it converts gases into carbon dioxide, water, and nitrogen, because car exhaust actually contains high levels of carbon monoxide, and carbon monoxide is deadly. So the catalytic converter actually passes the gases over a surface that will convert it to something else. There's a lot of research that's being done to find new catalysts, but also there's a lot of research being done to find inhibitors. So an inhibitor is pretty much the opposite of a catalyst. So a catalyst speeds up the reaction, an inhibitor actually slows it down. And you hear that term a lot when it comes to the drug market. So when you're looking at prescription medications, they focus a lot with inhibitors within the body. But a big example going along with cars is corrosion. So they're trying to find research in order to inhibit the rate of corrosion. So you want to find an inhibitor that will slow down the rate of corrosion. So the effect of a catalyst on a reaction. So I talked about what a catalyst does, and it decreases the activation energy. So you can see right here, the activation energy with a catalyst is substantially lower, or it can actually, well, by lowering the activation energy, it's stabilizing the transition state. So it's actually making that more stable to minimize the energy. And by minimizing the activation energy, we increase the reaction rate. So that is how a catalyst, or more of why a catalyst has an effect on the reaction. We've been talking about what the effect is, but now hopefully you understand more of the why a catalyst has an effect on a reaction. If you have any questions, just jot them down in your notes and bring the questions with you to class tomorrow.